All right. Like I said, I saw a few of you all walk in. If you all are network administrators already, this stuff is going to be a little bit basic. Maybe you'll learn something, but I'm pretty much just going to go over stuff that, as a network admin, we see on a daily basis, and a little bit of a foundation about when you see something, you got to just know it. I mean, this is the tech of sight words, you know. Just got to know this stuff, and you'll make a lot of decisions based on this stuff. So, a little bit about myself. My name is Rene Ramirez. I graduated from Baylor University. I double majored, one in MIS, which is Management of Information Systems, and one of them in Finance. I've been a managed service provider, which that means is that we walk into a company and we check out what their servers are and desktops and stuff like that, and basically tell them what they need, what they want, you know, and work on pain points and manage their servers and their desktops. I got a couple of techs that work with me on a daily basis, and we're busy all the time. Another thing is I own a software company. I own a software that's a logistics software, helps people get product across the border, does all of the paperwork and all of that stuff. That's used all over the world, from Colombia to New Jersey. Another piece of the software that we have some financial scrapers, parsers, stuff like that we have at several different offices for traders and brokers. My normal job, I work every day at a company here in town that's been around for about 70 years. It is a billion-dollar private equity firm. Basically, they own a lot of commercial properties, banks, retail businesses, restaurants. I mean, for example, they own all the Buffalo Wild Wings in Texas. And so my job is to take care of the networks, the software, the desktops, along with a couple of other guys here in town with their family office or the main office. And then I also do audits on some of the companies that they own. So basically, like tomorrow, I will be flying up and walking up with a couple of other accountants and stuff like that, and say, all right, everybody step away from your computers. We're gonna now look at your processes and your best practice. Show me your backups. Show me your verified backups and all of that stuff. So it's my job to look over the investments, the IT perspective of all of the investments that they have. So I've been doing that. I've been working there for 11 years. Doing the MSP I've had since like 2004. The software I've had year 2000. I mean, we've been doing that for a long time. All right, so here we go into the networking. This is a really quick slide on the protocol stack. Whenever you go start shopping for equipment and hardware, you'll hear this is a layer 7 switch or a layer 7 router, or et cetera. This is what they're talking about right here, is layer 7. That basically that's the application layer. I'm just going to go over this really quick, just because I just want you to know that you'll start to hear this term later. I'll go over it whenever we go through DHCP and routing and stuff. But basically, this is the detailed OSI reference model. It's the TCP kind of protocol that everybody has to. It's a standard, and here it is right here. But I'll go over this a little bit later. But I just want you to know that there's a stack, and the top is the application all the way down to the physical layer, the wire. All right. So the first real topic is IP classes. So does anybody here not know what an IP address is? All right, so I'll go over it real quick anyway, though. Whenever computers are on a network, every one of them has kind of a phone number, a number that's unique to them on the network, and that's usually depicted in 4 octets. Every spot in front of a period is an octet. So whenever you start talking about IP addresses, you start talking about the first octet, second octet, third octet, fourth octet. Really complicated on why those numbers are that way, but basically it has to do with bits, and each one is a 32-bit address on it. There are basically 3 private IPs, and so when I talk about private IPs and public IPs, the private IPs are what's within a network. So like let's say that I have a network in an office and all of the IP addresses are going to start with one of these three classes. The most popular one that everybody sees on their home routers, that comes with their home routers, is the 192.168 IP address scheme. The third octet usually has a number on it, but that's just basically saying that when the computers want to talk to each other, they know that we're all together, okay? Public IPs are not going to be in this range of IP addresses. Public IPs are what's usually on the outside of your modem. So this building that has internet, the gateway outside of the building has a public IP address. When you go hit Google, that's a public IP address. That means it's an IP address that can be reached from the internet. Your 192 numbers are not going to be able to be seen from outside the network. Everybody with me? Yeah. So each one of these are private IPs, and I just kind of want to point out real quick the ones that are mostly commonly used. The most common are the 192 numbers, and then after that it's going to be the 1010 or just 10 addresses. I usually always use 10, 10, 10, or I usually put a third octet in there. Then there's the subnet mask. Right, let me see if, yeah, so subnet masks are usually that number you see right under the IP addresses. That's 255, 255, 255, 0. So I'm not going to go into the details of that, but basically the ones that have a 0 basically say that this last IP address in a network can go from 1 to 254. So a network with machines of 192.168.1.1 all the way to 254, because that last one is 0. If you go jump back a 0, then you'll have this octet being seen. Did everybody kind of get that? I know that gets complicated. Any questions? This last IP address is reserved. It's called 127.0.0.1. Usually people call it localhost. Localhost means that it is the IP of the machine that you're at. So every machine on the network is going to be 127.0.0.1. The only one that can see it is itself. Get that? All right, so everybody's seen this that has done any kind of networking. This is where you put in the IP addresses. You'll see that this one, they decided to use 005 and open up all of the 255 net masks. And then we're going to go over a gateway here in a minute, and then we're going to go over DNS right now. So one of the things that, let me talk about DNS. DNS is basically, the definition is converts numeric IPs to familiar alphanumeric names. So www.google.com equals a 4-octet IP address, public IP address, okay? The only reason why there's a DNS out there is so that we can remember the name of it, all right? So if it's kind of like saying 687 Rene, that's my phone number, you know, and the RENE has a number associated to it. That's all that the DNS does, is that there's a DNS server out there that every time you put in a DNS server number down here, you're telling it, go to that server every time I put in www.google.com, go to that server and look up the number of google.com and send me there. Got it? So, what DNS server is probably one of the most popular ones used in the world? It's 8.8.8.8. It's Google's. That one, that's the DNS server for Google. If you're putting it into a router or something to that effect, you would put 8.8.8.8 down here and say every time that I want to go to, I don't know, Microsoft.com, then look up the number at Google and send me to that web address. One of the things that's very popular on a Windows network is that you'll have what's called Active Directory. Active Directory is when you go into a network and you see the login on a login page on a machine. That is Windows directory that you're seeing. That's the security. It's gonna bounce off the Active Directory and say whether or not that person has access or not. Then later on, it tells you what files are available on the network and stuff like that. So Active Directory is the management tool in Windows that says what security is provided to the user. And so DNS has its own, Active Directory has its own way of reading a DNS. So Active Directory will be on one server, and then your Microsoft Exchange email will be on another server, and so on. So what usually you do is you set up a DNS within the network that says, where is the Active Directory? Where is the Exchange server? Where on the network is this machine, depending on what you want to do. So on a private machine, you're not going to see a public IP address on the DNS. You're going to see a private IP on the DNS because the Active Directory, you want to hit the Active Directory, and then the Active Directory will then go to the 8.8 when he knows that, hey, that machine or that item is not on my network. All right? One of the ways that you can get around DNS is that on your Windows machine, you have a host file located there. It's called hosts in that directory. Everybody's been in the network business for a long time knows exactly how to memorize that line right there. You would then define an IP address and then a name. So here, 127.0.0.1 is the default, and if it's localhost. If you are on a machine and you go to a browser and you type in localhost, it'll look back at your machine. If you've got a web server running on your own machine, then it's going to look back onto that machine for that web host. If I decide that on a machine that I wanted to put Rene.com at a certain IP address, whether it be in the network or outside the network, I can easily just hard code that DNS into the host file. Okay? Everybody with me? Question? No? Don't be scared. All right, so one of the things that you see a lot of commercials for is GoDaddy or register.com, and now Google has their own registry or registrar. And so what that registrar is that if I want to do Rene.com, I go to GoDaddy or one of these people and pay the $30 a year, the $10 a year, $2 a year, depending on the special, and say, I want to own Rene.com. So that registrar says, okay, I'll sell it to you. What public IP address is your web server? What public IP address is the actual page that's going to show whatever it is that I want to show on my web page? Let's just say that it's 888.1, okay? So then I go in there to the registrar and I say, if anybody goes to Rene.com, send them to 888.1. And so what Google does is there's some big master DNS lists out there, and Google is probably one of the fastest, but the registrar will then send that information over to the DNS servers out there, the master DNS servers, and that's how your machine will know to go to 8.8.8.1 to pull up my web page. Okay? Got it? Now remember, there's keywords down at the bottom on your sheets. If you want to know more about DNS, tell me. All right, next is DHCP. So DHCP, the definition is provides a host with an assigned IP address and other related information such as gateway and DNS settings. All right, so a little while ago we had a slide up here that you got to choose to put your own manual IP address into the computer that you were at, okay? If all y'all look at that have a laptop, a phone, iPad, whatever, you're going to see that there's been, and you're on the Wi-Fi here in the building, you're going to see a private IP address has been assigned to you. It's been assigned by a DHCP server. So all of y'all probably have it set right here to obtain an IP address automatically. And so what that does is it turns this off, turns that on, and basically says that when I connect to the Wi-Fi or when I plug my computer into the wall, something out there, give me an IP address. All right? Give me an IP address that's open and that you want to give to me. So those range will pretty much always be in a private IP address. So here, let me go back to TCP. All right, so that covers static versus dynamic. Static means that you yourself are going to put an IP address in the machine. You know, we usually use static IP addresses on servers and devices that are on the network that are never going to leave. What's that? Hardwired into the network and ain't ever going to leave. You know, the access point that's up here in the ceiling is never going to leave. So it's going to have an IP address already assigned to it that's static. And then our laptops and our phones and all of that stuff that come in and out of the building, those get a new IP address pretty much every time. And so that'll have a dynamic IP. So I usually have a best practice for assigning static IPs on a network, okay? I usually put the servers on the .200 to 250 fourth octet on a server, on a network, okay? Some of the smaller ones we do 10 through 19 just because there's not gonna be that many of them. Printers, we always put them, I do, you choose whatever you want, but I always put them on anywhere between 50 and 74, just so that I know that the reason I do this established network scheme is so that I know when I'm going to assign an IP address to a server or to a device, I'm not going to reuse one, and then you're going to have what's called an IP conflict, and you're going to have a mess on your network. So the printers, 50 through 74, access points and static devices like that, I usually put 20 through 29. Gateways, I usually put 1 to 5. Now, I'll go over gateways right after this, but gateways I usually put 1 to 5, and then, so a little while ago when I talked about a dynamic IP, an IP address that's given to you, I usually put those between 100 and 199. Everybody has different things. You know, it used to be that when you bought one of these home routers like Linksys or something like that, they came from 100 to 200 or something like that. And now I've noticed that they're coming from like 2 to 254. They're widening that range. But basically, this limits you to how many machines can actually connect to the network. So on this particular network, I'm only going to have 99 machines or 100 machines coming onto the network from the outside. If you start changing the subnet mask and the third octet and the second octet on those private IP addresses that I was talking a little while ago, you can establish this range a lot bigger. Because right now, if you'll notice, you only have 254 addresses on this network. So because 192.168.1.1 and all the way to 254, that's your 32 bits that we were talking about in the fourth octet a little while ago. That's all you can have on a network without changing that third octet to another number and changing the subnet mask. Got it? Okay, so lease time. This lease time is associated to dynamic IPs. Lease time, the best practice on them is 8 days. Usually what that means is that when I showed up today with my laptop and I got an IP address from the network, the next time I come, my machine is going to have the same exact IP for the next 8 days, or since the 8 days that it's seen me last. If I come in 10 days, very, very big chance that my IP is going to be very different than the last time that it was here. So the reason I talk about lease times is because the Dhcp then reports back to the DNS server. Or the DNS server basically said what names are out there. And so on a private network, your DNS server is keeping track of all of the machines on the network. So if I called a server, Optimus Prime, okay? That's the name that I decided to name my server today. The next time that your machine comes into the network, and you type in show me Optimus Prime or get me to Optimus Prime, he's going to know what IP address it was based on the DNS server. The DNS server is going to say Optimus Prime, that's the IP address I'm going to point you to, and you'll be able to get data. That's what you use in order to get files and all of that stuff. So what happens to a lot of people is that they put a computer on a network that has a printer attached to it. And today they turned it on and they shared that printer off, and then they turned it off for about 10 days. And then before that, the other machine was able to print to it, share off the share. And then you turn it off, 10 days later, that machine's trying to look for that share, the name, and he can't find it. And because it's using a different IP address. So the common issue is that if you have other machines that look for a certain machine every time it turns on, that machine should have a static IP address because the numbers are going to change all the time. DNS, it can only keep up with it so fast. It polls it. Usually the Active Directory usually polls the network once a night and says, all right, what machines are on my network? And that IP and the name of the computer are this. And I'm going to put it into this index so that if another machine on the network comes and looks for it, I know where to send them. Usually, this dynamic IP scope, I use it. I use it every day. We use it in a practical sense. If you go and do like the CompTIA exams or the Microsoft certifications, what they're going to want you to say, and it doesn't work very well in theory, and it works very well in theory, but it doesn't work real good in the real world, is that they're going to say, give me set up your dynamic scope from 1 to 254, everything on the network, and then set up a little index that says, the server is here, don't assign an IP address there. Okay, that's what it wants. But I'll tell you, that's a mess. You go to a network and then suddenly you have conflicting IPs. It works really good for an exam, does not work real good in real life. All right, so the fun stuff: gateways, routers. Who here has set up a home network? Did you have to go into your router and set up the IP addresses and do all that stuff, or you just plugged it in the wall and went? No, everybody. Yeah, the wizard, right? Okay, so what I'm going to talk about today is the purpose of this router. All right. So definition again, right? Routers are a network device that forwards data packets between networks. It's kind of vague, but that's the wiki term, wiki definition. What this does is that when your computer types in a name like google.com, and he then gets the DNS, and he says that google.com is at an IP address, my computer's going to start looking for that number, okay? And he's going to go to the gateway. All right, remember when we were setting up IP addresses, one of the things that we had to do was set up a gateway. So your gateway is always going to be your router, the way out of the network. Or better yet, the thing that's going to make a decision on whether you should go out of the network or stay within your network. So the Google IP address is not within those 3 private IP classes, okay? So your router is going to say, hey, that IP address for Google, it doesn't belong within this network. I need to go outside the network to find that information. So what that does is it jumps out your modem, jumps to the next gateway, which is your internet provider, and then it jumps until it finds the IP address that you're going for, which is Google. Okay? If my computer on the internet that is in my network, it looks for a 192 address, something that the DNS has interpreted as a 192 number, it's going to look within my network for that machine. So that's what's making that little decision is the router. Okay? Some people with multiple internet services will then have more than one router, and then the machine is whatever gateway that machine has been set to, it's going to go out that router. Okay? So at my house, I have 2 internet services, and one's just kind of a failover, and my router is making a decision on what gateway to go out. My machines are say, hey, but the DHCP comes out of the router, goes to the machine. It assigns it an IP address, a gateway, subnet mask, and DNS. Okay. So, gone over. Let's see. I'm sorry. I've kind of lost myself sometimes. All right. So the difference between a router switch and a managed switch. Okay, people always ask me, what's the difference between a router and a switch? And then the next question that people ask me is, what's the difference between a switch and a managed switch? All right, so a switch, think of it as just a splitter. It's just a splitter. That's all it's going to do. There's no decision being made. It's just a way to bring all your machines together onto one network, and all of them are just sitting there, okay? No decision is being made. Decisions are made by a router. Routers usually have the DHCP server on them. Routers usually have the DNS server on them on less complicated networks. So more complicated networks, you put a server that's a DHCP server, you put a DNS server, but your home networks, your router is going to be doing all the work. A lot of businesses, I mean, small businesses, that's good enough, a router with a DHCP and DNS. So next, that's the difference between a router and a switch. A managed switch is a smarter switch. All it is that there's something out there called VLANs. It's a security way to get networks divided. It gets complicated. And then it can usually tell you how much data is going in and out of each single port. You can assign different ports to do different things and different networks. That's the difference between a managed switch and a regular dumb switch. Most of the switches that you buy at Best Buy, regular switches, managed switches, you're looking at a few $100 more. Drew just brought me some that belong to me. Each one of them was about $1,500. They're extreme switches. They're really big managed switches. But so that's the difference between router switches and managed switches. I went over the routers have the DNS and DHCP on them. All right, so ports. Ports, you're going to hear that a lot. Open your port. You'll hear that in some of, if anybody download music or something to that effect. But in a network, in a real live business network, you will usually have, you have your internet, then you have your router, and then you have all these servers, right? And then you also have all these desktops, okay? Let's say that within your network, you want to put a web server. Basically, the popular ones are, the Windows one is IIS, the Linux one is called Apache. So I want to host my own websites at my house, okay? So on a router, you have what's called the WAN side, and you have what's called the LAN side, okay? The WAN side is going to be your public IP address. So anybody on the anybody that's on the internet that's going to be looking for your network is going to have to know the public IP address. All right? That public IP address, if you've gone to a registrar and registered that IP address, you can have then a name associated to it. So we're going to do Rene.com, right? Rene.com, we said was 8.8.8.1. Right? So we're going to say that this WAN side of this public side of the router is 8.8.8.1. All right? So the rest of the world, when they hit Rene.com, they know to go to 8.8.1, and then through some internet magic, they show up right over here on the WAN side. That's those gateways everywhere that we talked about. So then they're going to be hitting this router, right? Well, a router usually on a network is also your first point of entry, so it always has some firewall stuff on it. Basically, it says, do not enter. You cannot enter and see anything that's on this network without me letting you in. All right? So on a router and on TCP IP, you have these 6,000 or so little ports of entry, little pipes, okay, that are automatically closed on the router when you buy it. Anytime you go to a web server, it's just one of those things that everybody knows that port 80 is the port that a web server should sit on. Okay, when you type in Rene.com on the browser, automatically it knows to go to port 80. That's the default one, unless you tell it to go to a different one, okay? That's what happens every time you go to Internet Explorer, Firefox, Google Chrome, whatever. It automatically puts a :80 at the end of your address. So, all right, so we're going to go to this IP address at port 80, right? So then you work your way into the LAN side, and the person at the other end that wants to see Rene.com is knocking on the door of the IP address on the little pipe that's marked as 80, okay? So, all right, so we're going to open up 80 to go see the web server, right? So what we do is we open up port 80 on the router, and we say that, let's just say that this server is on 192.168.1.5, right? That's the private IP address that we've assigned to that server. We tell the router, anytime somebody comes knocking at port 80, go to 192.168.1.5, okay? So now this web server knows that when you've walked in, you've looked for the Rene.com web page, and it's going to serve it up. And it's going to send it right back out to the other person. You came knocking at 80 in the right one. So a firewall essentially is one of the things that the firewall does is basically act as your gatekeeper to say what can come in and what cannot come in. And one of those things that can't come in are certain ports, data through certain ports. Other more advanced server firewalls start looking and inspecting the data, making sure that the data is not bad data, or that somebody's hitting the outside of your router, and so on and so forth. But basically, that's what ports are. Okay, different software uses different ports. If you're a downloader of music, you'll say, I don't know if anybody uses uTorrent or something like that. It says, oh, this is the port that we want you to open on your router so that we can connect outside, so that things outside can come in and talk to your machine on the inside. So that's what you do on your routers. You open up a port. All right, so the other thing I was going to cover real quick also is VPNs. VPNs, all it is that, okay, let's talk about this router right here that I have at my house. Okay, and at my office, I have another router over here. Okay, and so I want to talk to a server that's inside here that gives me files. Okay, Word documents, PDF documents, so on, so that I can work from home. So what I would do is I would create what's called a VPN between these two. Here's the internet. And I tell this router that, hey, there's a VPN router sitting at this public IP over here. I would like to make a connection between that router and me. Then on this router, I say, allow a connection from the public IP that's over here, and I then can go back and talk. Okay? And so what I have done is I've created a little sub-pipe through the internet that just can be seen by me. This router is going to say, anything that's coming out of this router over here can go inside my network and just pretend like this desktop that's over here is sitting inside this network. Okay? So I'm going to say that I want to see, let's say this one right here, this server is 10.10.1.5. All right? So then I would go on this desktop and say, I want to see the server that's at 10.10.1.5. It's going to go and ask the router, hey, I'm looking for 10.10.1.5, and the router's going to know, hey, that IP scheme, that 192 scheme, that belongs to me internally. And that 1010 number is also not a public IP address, that's a private IP address. So the desktop's going to go to the router, say, give me 1010. He's going to know it's a private one. He's going to look to see if that server then exists to the other side of the VPN and send the data over just as if I'm on the network.
I don't know if this is way off base, but is that kind of how like Xbox Live used to work?
No, I don't think so.
Back before Xbox Live existed, I remember connecting my Xbox to a computer, and that computer to some outpost.
I don't know.
This is the way hackers get into the servers.
Yeah, so VPN is still one of the most secure ways of connecting basically your home network to your office network, or this is also used in companies that have multiple locations and they need to access the same data or same servers on both locations. You'll connect the two through VPN. One of the things that, go ahead.
What's the best way, let's say, I know you can control the access to your internal network for your users, like where can you go? But let's say all of a sudden you need a consultant to come in through VPN. I mean, the way you see it is once his desktop is inside the network, it's like you're inside the network.
Okay, so.
Is there a way to kind of say only restrict them to this server?
Yes, so when you are setting up this router right here, you can say that this router can only see IP addresses from 5 to 7, or only see 5, okay? Now, this side doesn't necessarily have to be a physical server. It can be a dial-up program from a laptop. One of the most popular ones is Cisco Vpn. Cisco Vpn, you install it on your machine, you tell it the public IP address of this router here, you put in the credentials will then go to the router, and the router will then say, your credentials can only see 5 through 7, or servers 5 through 7. Then you're going to have the issue of Active Directory, then they're going to have to be able to have access to these files here that they have access to.
You can also create blocks or a folder that is your server, correct? I mean, within a server.
Yeah, so the way that file sharing works is that on a server, you're going to have your, let's just say the C drive, and you're going to have one that's called Share 1, and you can have your C drive, another folder called Share 2. Well, I'm going to say that this folder right here can be seen by this set of users, and this folder here can be seen by all of those users plus 2 more. And that's how you would do that. In Active Directory, you go to the folder, you right-click it on Windows, and you say Share, and then it's going to say Permissions, and you put in the usernames, and that's how you start to share off files on a server. Everybody got that? Can you set up a VPN for me today?
Can you tell me about the cloud?
I'm going to teach you about Dhcp here in a minute.
In the previous explanation, it seemed like router was on a different level of sophistication than server.
So router,
no matter what.
Yeah. So you're going to have a physical device, and I have a home router here. That's your router. That's a home router. People use them as wireless access points. It's got the antenna built in, and basically sends everybody that connects to it gets an IP address and so on. On the back of a router, that was going to be. I'm going to talk about the WAN side and the LAN side. So most of these home routers have one port singled out completely, and then 4 ports all grouped together. This is going to be your LAN side. This is the part that connects to the internet or the modem, and that's going to have the public IP address side. And then this is going to be the splitter side. You can daisy chain splitters. You can put one on this side over here. If you run out of ports because you have more than 4 machines, you put it on a switch, and you've got 10 more. You have 8-port switch. You got 7 more ports because this is going to use one of them. So you can daisy chain them. So if this room I needed to put 7 machines on and only had 1 port, I put a switch right here at this wall and give out everybody a connection. And so that a server, choose your server. A Windows server, Linux box, whatever.
Do you know what the best router right now is?
One of the 2 competing best home routers is one by ASUS, and it is, oh man, they look like stealth fighters. Yeah, man, I wish I knew which one that was, but I can look it up real quick. The stealth fighter looking ones, and Asus has one that is almost called the same exact thing, and looks almost exactly the same. And those are those. So whenever you talk about routers and speed and all of that stuff, so each one of those ports has a speed, 10-100, 10-1000, whatever. That's the speed but that's not always the speed. You may have a gigabit switch, but one switch may be faster than the other. So the more managed switches, the bigger switches, they have bigger processors, bigger caching, bigger RAM to make the decision on where to go based on those IP addresses faster. So when you have bigger networks and you're moving media, music, things of that nature, the better router that you go, the better performance you're going to have. I had that problem in my house. I had a Cisco Meraki access point in one point of the house, and we had a Chromecast. Everybody know what a Chromecast is? Plug it into the TV, you can watch Netflix, so on. Well, or music, whatever. You put it on the TV. So that Cisco access point, for some reason, was always blipping when in the middle of a song or something to that effect. The Cisco Meraki that I was using wasn't really designed for pushing media through it. And so I used another one called an Airtight, and then suddenly it all moved a lot faster. But each one of them, both of them 802.11n, both of them had gigabit ports on them. It was just that the internals of it, the processing speed and all that stuff, moved the data faster.
And those routers and the home routers, can you prioritize some of whatever?
So that's what he's talking about, is that data coming out of behind the router and onto the internet, sometimes some things need better bandwidth than others. So at my house, my wife works from home, and she has a Cisco VoIP phone sitting at her desk connected to her office in Atlanta. Okay, when she picks up the phone and wants to call Atlanta, and I'm downloading a movie in the other room, what a more sophisticated router is going to do is called quality of service, and that'll basically say that any traffic that you see on the network that's voice traffic, send it through before the movie traffic. Okay, that's where we start going into layers. Okay, the application layer, the different layers of things that are coming through. The 7th layer is your applications, and you'll be able to make some decisions on some better routers that say, okay, when this information is going through this router, give it priority. So I notice on a lot of networks that Dropbox uses a lot of bandwidth. Okay, everybody on the network has a Dropbox on their machines, and nothing is happening, and everybody's complaining that the internet is slow. Okay, so what we would do then in that situation is get a router that has application or layer 7 management, and I would say that if you see Dropbox traffic coming through, give it lower priority and give it less bandwidth. Okay, that's where your layers come in. Layer 2 is where your DHCP works, because when I walked in today with my machine did not have an IP address. So when I plugged it in or connected to the wireless, it started looking for an IP. That's on the layer 2. Okay, that's not a big deal. But this week I ran into a switch that has been working just fine, and people started walking in, they couldn't get an IP address. Okay, layer 2 is out on that switch. Okay, so nothing was wrong with the DHCP, all of the leases were open, so on. So we got them a new switch. But application, the more popular thing that you're going to start seeing on business routers these days is application or layer 7 handling. Because there's so much work being done on the cloud, and there's so much work being done over across the network, that it is now more and more important to prioritize certain applications over others in a network. It used to only be QoS for VoIP, and it said, hey, that little 12K that's coming through of voice, let it through faster or better, and don't let it chop, because TCP IP, when it's running across a network, does some auto corrections. If for some reason there was an interruption in service, it does some corrections, and whenever you start working with VoIP, it gets complicated with latency and stuff like that, that your voice doesn't flow. So maybe you've been on a VoIP call, or somebody in India getting support, and they start tuck, like that, it means that the network has gotten choppy and something's happening in the middle. And something's not giving that QoS.
I think that's it. I have a really simple question, back to routers. I gathered what you said, that between the, I'll say between the yellow input and the blue outputs, when something happens. It's not just straight through. Right.
Yeah, so that router, it's making a decision of, am I looking for an IP address that's within my network, or am I looking for an IP address outside my network? And so then that router will decide to say, look back inside my network for that information, or do I go to the internet for the information? Or do I go across the VPN or whatever?
And as a practical matter, that means when things aren't working right, it does make a difference if I unplug it out of the router and plug it directly in the computer.
So what you've just done, though, is now you don't have a firewall. So your machine now has a public IP address. Okay, and and your Windows has a built-in firewall and stuff like that, but your machine will start getting hammered by people looking for Windows machines. It's very possible that you'll get a better connection, but we're talking about milliseconds. I mean, we're not talking about a lot of data, but you would, as a practical sense, always have a router in the middle.
That leaves the router out of the picture.
Right. So if you're trying to figure out whether your router is broken or not, what you would do is then you would turn everything off, because what's happened is that usually the like Time Warner and AT&T routers or modems only give out one public IP address, and they marry it to your router or whatever's been connected to it. So what you need to do is when you connect it to your machine, you turn off the modem so that the modem then assigns you a new IP address and marries your machine to that IP address. So you have to turn everything off and then turn it back on. And that's why they tell you to turn things off in order, because DHCP is happening.
How much should you spend on a router? Work, as in work, because I know sometimes, let's say my wife says, make sure that the girls farm on the internet has, let's say, 10 o'clock. Now I can get on the router, but to go in and try to drop their phones off or not allow them, is there like a way that you can say, hey, between this time and this time, do not allow these devices?
So I know that the router that I just brought in and all your basic home routers have what's called bandwidth scheduling, okay? So basically then you would say is that no machine past 10 o'clock to 6 a.m. can get bandwidth. They can talk within themselves, but they can't go out to the internet. And what I'm doing right now is I'm looking for that Netgear router.
Netgear or Linksys? Like, which one's better?
I've seen them both blow out just as much.
What's your favorite brand of router?
For the small businesses that I usually take care of, I put what's called a Sonic Wall. Sonic Wall was usually was recently bought out by Dell. If you talk to Drew, who's my competitor, he likes to put in what's called FortiNets. FortiNets, Sonic Wall, do the same thing. It's just that I know how to configure a Sonic Wall a lot better.
Lies, it's all lies.
What I like about the Sonic Wall is that I can also manage antivirus on a network with it. So I can.
He gets to replace it all the time because it breaks.
Nah,
You didn't tell me.
I sell licenses. No, so what happens is I can say on a network, if this machine does not have updated antivirus, it can't go on the internet, it can't connect to anything, nothing, until it downloads McAfee. So that's why I like Sonic Walls better, just because. Well, why McAfee? Because that's what comes with a Sonic Wall. They're all trash, as far as I'm concerned. Kaspersky, Norton, everything gets a virus. The only thing that is, as a network admin or a managed service provider, what I look at is how tough is it for me to manage. And if I'm having to manage 1,000 people, which one would I rather have as a management tool? The Norton management tool I've always found is very cumbersome, difficult, and When I send a tech out in the field to them, they don't know what they're seeing. And if you look at the Sonic wall in a McAfee, the control panel is easy. Either it's on or it's off, and that's it. Yeah, Sonic Wall was recently bought out by Dell, and ever since then they send me an email every single day trying to get me to sell more Sonic Walls. Sorry, I'm just going to look real quick for that router. It's called a Nighthawk, the Netgear router Nighthawk. The one they were asking about, the one that processes faster. And Asus has one that's kind of like the Dayhawk or something. I mean, it's just this real close name, looks exactly the same. Any other questions? No? Everybody get it? Yeah, you learned something today, hopefully? Yeah? All right, well then, put in your evaluations, and if you want to know some more, like I said, the next one is January 15th, and they're going to do, I think, .NET and C#. If not, I will bring in the Sonic Wall, and we will configure one together. Thank you.